Hey everybody, so we are going to do problems 94 and 95. They are not the 94 and 95 from the book, just to let you know they are problems that I have made up to do notes. And so no need to read the book, this one, it's all made up. Okay, so I'm going to start with title here, notes, geometric series, and summation notation. We're going to do both of those types of problems for one example. And so we're going to start with an example. So first, actually, I want to say geometric sequences have a common ratio, which we call R, and are created by repeated multiplication or division. Okay. So to start out with that, just so that we know, geometric sequences, so we have an example of 4, 8, 12, no. That's funny, that would be arithmetic. 4, 8, 16, 32, ... And this is important, I am saying that this is going out to 16 terms. Okay, so just to remind you, you have term 1, term 2, term 3, term 4. And this particular geometric sequence goes out to 16 terms. Just gets really big, so we don't keep going by writing them out. Okay, there's a couple of things you need to know for this, and that is how to write the equation. So you have equation. Okay, and there are two ways to write this, of course, because you can write it in terms of the 0th term or the first term. Okay, so t of n equals, if we want to write it in terms of the 0th term, which is what we usually do, the 0th term comes first, so t of 0, and then the multiplier or the common ratio to the n. Or if you want to write it in terms of the first term, that would be t of n equals t of 1 times r to the n minus 1. Okay, and those are both exactly the same thing. Moving this to t of 1 and moving that to n minus 1 cancel each other out, basically. Okay, so how would I write that for this particular problem? So we know that there would be a 2 in front for the 0th term, I can tell, and then I can also tell that this is increasing by multiplication of 2. If this is very difficult to tell just by looking at it, you can always find r by taking the second term, dividing by the first term, and it doesn't have to be these two, it just has to be 1 on the right divided by 1 on the left equals 2. And then remember, you do the opposite of that to go backwards. So if I'm moving down the sequence and multiplying by 2, I want to divide by 2 to go backwards to find the 0th term. Okay, I don't love this because the t of 0 is 2 and r is also 2, but I think we can do it. So t of n equals t of 0 is 2, that's this 2 in front, times 2, which is this ratio to the n, and this is 0th and r, okay, or we could write it in terms of the first term, t of 1 is 4 times 2 to the n minus 1. A little bit less work, but a little bit more complicated here. Okay. Just a note that if you have t of n and you want to find the number of terms, you might have to log both sides. I'm hoping that all of our log work from previous chapters will help there. Okay, so now we're going to move this into a series. Okay, and we're going to use the same example, except it has pluses between. And making sure that we know that this stops at 16 terms. So this is very important for understanding the next section coming up after this. Geometric series, in this case, will stop. Okay, so the first thing we're going to do is find the sum. So find the sum is first, and the sum formula we learned earlier, S sub n is sum equals t of 1 times r to the n minus t of 1 over r minus 1. Okay, and this stands for sum, just a big S for sum. Okay, so t of 1 in r's is the first term here, which is 4, times r is 2 to the n, which is 16 terms, minus t of 1 over r is 2 minus 1. Now when you do this in the calculator, remember parentheses around the top, parentheses around the bottom. And this comes out to, let me go to the calculator here, 4 times 2 to the 16 minus 4 divided by 2 minus 1. I know what 2 minus 1 is, but okay, so we have 262,140. Okay, so that means if I listed all of these numbers, I kept going 64, 128, 256, blah, 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 out to 16 numbers, and I added all of those up, the answer would be 262,140. Okay, now we are going to write this in summation notation. Okay, and I'm going to do it two ways. That's because I have two different equations. Okay, so what you want to do is start with your big sigma. Summation notation always starts with a big sigma. And I want to put the equation right here. So I'm going to use the 0th term right underneath. 2 times 2 to the n. Okay, notice I just took this equation here, put it here. This is the 0th term. This is the multiplier to the n. And then the last thing I need to do is tell it where to start and where to stop. So up here, I wanted to start at the first number and end with the 16th number. So I'm going to tell it to start by plugging in a 1 for n and then stop at plugging in a 16 for n. Okay, so this would look like this. 2 times 2 to the 1. 2 to the 1 is 2 times 2 is 4. Then sigma means plus. Okay, then we go to 2. 2 to the 2 is 4 times 2 is 8 plus dot dot dot. Okay, can you guys see how this is coming out to match that? And then the answer would be the answer we got from our sum equation. Okay, the other way is to write it in terms of the first term, which is 4 times 2 to the n minus 1. It doesn't change anything about where to start and where to stop. It's just written in a different way. Okay, so plugging in a 1 here. 1 minus 1 is 0. 2 to the 0 is 1 times 4 is 4. Going up to 2. 2 minus 1 is 2. 2 to the 2 is 4. No. 2 minus 1 is 1. 2 to the 1 is 2 times 4 is 8. Okay, so this is supposed to be keep bringing out exactly the same series we have here. And then, oops, I wanted that to be equals 262,140. Okay, so I think that is everything you need to know for geometric series sequences, finding the sum, putting it in summation notation, and this is going to count as problems 94 and 95. Come on, camera. Come on. Count as problems 94 and 95, and we are going to actually skip the homework for this, and then I'm going to do another problem for the next section, and you'll have that homework. So I am trying to condense the stuff into the most important things for you, so that you don't have a lot of busy work. Thanks, guys. Talk to you soon.